Hi y'all, Chris here from Lewis County Head Start, and today we're going to do a little science experiment. And what you'll need for this experiment is at least 6 feet of string, a balloon, a straw, some tape, and preferably 2 ends that you can tie the string to. But first, we're going to talk about a little bit of physics and what is going to happen in our science experiment. So first, a man named Isaac Newton, who was born in 1642, he is known for creating the theory of gravity, calculus, and the laws of motion. And those laws are what we're going to start talking about in this video. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force, commonly known as inertia. And what that means is if an object isn't moving, it won't move until it's bothered. And then it'll continue in that path until it's bothered. Newton's second law of motion states that the force exerted by a moving object is equal to its mass times its acceleration in the direction in which it's pushed. So for example, a bicycle, the harder you push on the pedals, the faster it'll go. And so when you start off, you have to push really hard to get it to move. And the harder you push, the faster it goes. And that's an example of Newton's second law. And the experiment we're doing today is Newton's third law. And it states for every action, there's an equal and opposite reaction. The statement means that in every interaction, there's a pair of forces acting on two interacting parts. The size of the forces on the first object equal the size of the forces on the second object. So in our experiment today, we are taking the string and tying it to 2 different ends really tight. And we're putting a straw in there, and we're taping a blown up balloon to that straw after we blow it, So as we can see, I've already attached a very long string to 2 chairs. And inside that string is our straw, our balloon, which is held to the straw by tape, and our little clothespin. And so Newton's law states for every action there's an equal and opposite reaction. So if I remove our clothespin, what do you think will happen? Will it stay there, or will it travel along the string? Let's find out, shall we? So I'm going to come over here and remove our clothespin. Oops. Hope so I do it right. All right. 3, 2, 1. And so what happened was, when the air leaves the balloon, it pushes it outwards at a rapid rate. And thus, when it expels all the air out, it creates a force which generates momentum, thus propelling the balloon from down here, or to here, from all the way down there. So again, that's Isaac Newton's third law, and that is for every action, there is an equal and opposite reaction. And so the action is the air rushing out of the balloon, and the reaction is the balloon traveling. And so I hope we had fun today. Now this will be a really neat experiment for you and a friend to do. You can make little races out of it. Okay. So that's all the time for now. Bye.